Hello, let us look at second order differential equations. So here we have y double prime plus y equals e to the x plus x cubed. Now, first we'd like to find the complementary solution first. So we like to use the characteristic equation plus 1 equal to 0. Then you can easily see that r should be equal to plus or minus I. Since it's a plus or minus I, what we end up getting is complementary solution would be c sub 1 cosine of x plus c sub 2 sine of x. So we got that one done. Now, second, the fact that we were able to get e to the x, then let me just separate this one in two different cases, because if y had e to the x, no matter how many times you take the derivative, it will never be equal to x cubed. So we have two different cases here. First one will be y sub p sub 1, let me just call it that way, could have been equal to a times e to the x. Then the y p sub 1 prime is still a times e to the x. Y double prime of p sub 1 would have been still equal to a e to the x. But when I add up these two, it has to be equal to e to the x. So in other words, 2a e to the x is equal to e to the x. Then you get to realize that a must be equal to 1/2. So first particular solution would have been equal to e to the x over 2. Now, second one is, how can you get x cubed? So only way that's possible would have been, let me just call it ax cubed plus b x squared plus cx plus d. And then the y prime becomes 3a x squared plus 2b x plus c. And y double prime becomes, we get 6ax plus 2b. Now, what I'm going to do is I'm going to add up first one and third one, because that's what's happening here, and then has to satisfy this one. So when I add up those two, ax cubed has to be equal to x cubed. That tells me that a has to be equal to 1. And then obviously bx squared plus nothing has to be equal to 0, so then you get to realize that b must be equal to 0. Thirdly, cx plus 6ax has to be equal to 0 as well, so then we get to realize that a is equal to 1. So 6 plus c becomes 0, so that means c must be negative 6. Lastly, d plus 2b has to be equal to 0, but b was already equal to 0, so therefore d has to be equal to 0 as well. Alright, so then what does that mean? That means second one would have been x cubed minus 6x would have been my second part of the particular solution. So then let's write it. What is y equal to? It will be c sub 1 cosine of x plus c sub 2 sine x plus e to the x over 2 plus x cubed minus 6x. That's basically what we end up getting. But we had two unknowns. When you plug in 0, we get 2. So let's try to plug in 0. And sine of 0 becomes 0. This one becomes 0, 0. So this becomes 1/2 when x equal to 0. Then cosine of 0 equals 1, so we have c sub 1. And then 0, and then we have plus 1/2, 0, 0. Has to be equal to 2. Then I realize that c sub 1 must be equal to 3 over 2. Alright, so let's look at the next one. When I take the derivative and then plug in 0, I should be getting 0. So let me take the derivative here. Y sub y prime is negative 3 over 2, because c sub 1 was equal to 3 over 2, sine of x plus c sub 2 cosine of x plus e to the x over 2 plus 3x squared minus 6. So when x equal to 0 now, this one becomes 0. So we have c sub 2 left. Here I get 1/2. That's 0 minus 6 has to be equal to 0 as well. Then you get to realize that c sub 2 must be 11 over 2. So I know c sub 1, I know c sub 2. Then I think we are able to get final answer here. My final answer should be y equals 3 over 2 cosine of x plus 11 over 2 sine of x plus e to the x over 2 plus x cubed minus 6x. Whoosh, that was long. That was our solution for this question. Now, then let's look at number 9 here together. So in this case, y double prime minus y prime is equal to x e to the x. Now, then what we can say is to find the complementary solution first. So we can say r squared minus r equals 0. Then you can see that r must be equal to 0 or 1. Now, what's going to be happening is those two will give us a complementary solution, which is equal to 0 get you c sub 1, and 1 get you plus c sub 2 e to the x. So that's the first step. Now, second, knowing that our result has to be x e to the x after first derivative and second derivative put together, then at most y of the particular solution could have been ax squared plus bx, and then e to the x. Now, then what do we end up getting for the y prime? It would have been 2a x plus b times e to the x plus ax squared plus bx e to the x. Now, if I realize that e to the x is common, so if I were to factor e to the x and then combine the like terms, then we get ax squared, and then plus 2a plus b x plus b by itself. All right, that's what we have. Now, how about y double prime? Y double prime, I'm going to take the derivative from here actually, that'll be easier for us. Take the derivative of this one, we get 2a e to the x plus 2ax plus b times e to the x. And when you take the derivative of this second term here, when you take the derivative of the first component, that's equal to this one anyway. So we have two of these going on. And then plus ax squared plus bx times e to the x. Then if I were to reorganize them by factoring out e to the x, we have ax squared and then in terms of coefficient of x, I have here plus 4a plus b x. And in terms of constant, I have 2a here and then plus 2b. All right, so what we want to do is we want to have this expression minus this one. Then in terms of a's, they cancel away, so we don't have to worry about it. How about x's? 4a plus b minus that. So we get 2a has to be equal to 1 because b's cancel away. Oh, actually, in fact, we have we forgot 2 has to be distributed here, hence we get 4a. Oh, actually, that one was the other one. So 2a plus b. But b cancels away, so we get 2a is equal to 1. Sorry about that. And lastly, here we get 2a plus b has to be equal to 0 from the constant. Then we get to realize a must be equal to 1/2. Then b must be equal to -1. All right, so let's try to use that to figure out what we end up getting here. And then if I had a constant, then they would have been done over here anyway. So let's try to look at it. So what do we end up getting, guys? Our particular solution would have been 1/2, or x squared over 2 rather, minus x and e to the x. So our y should be equal to e to the x squared over 2 minus x plus c sub 2 plus c sub 1. Now when I plug in 0, it should be equal to 2. So what does that mean? When x is equal to 0, this one becomes 1 and 0, 0. So I'm left with c sub 2 plus c sub 1 has to be equal to 2. Now when I take the derivative, that's the one equation. When I take the derivative, then I'm going to, c sub 1 disappears, of course. So we have e to the x and x squared over 2 minus x plus c sub 2. And then plus e to the x 2, well, it simply just becomes x here, minus 1. And when I plug in 0, I should be able to get 1. So when x is equal to 0, 0, 0, so we have c sub 2 left. And then this becomes 1 and then 0, minus 1 has to be equal to 1. Then c sub 2 equals 2. Now, since c sub 2 is equal to 2, what do we end up getting for c sub 1? Then from this equation, c sub 2 is equal to 2, then c sub 1 is equal to 0. So I think we got final answer. Y equals e to the x squared over 2 minus x plus 2, and c sub 1 is equal to 0. So that becomes our final solution. All right. See you later.